Hello, chemist and biochemist. In this video, what I'd like to talk to you about are a couple of important terms that relate to sugars and structures and relationships between different types of sugars. So, with that said, these are the four maybe most important terms when it comes to sugar structure: enantiomers, anomers, diastereomers, and epimers. Now, what do they all mean? Well, enantiomers are examples, or enantiomers are my cursor, molecules that are mirror images of one another. Okay, so as an example, which we'll look at in just a second, L-glucose and D-glucose, they are mirror images of one another. So here they are. On the left-hand side, we have D-glucose. On the right-hand side, we have L-glucose. If we put a plane between them, well, L-glucose would be the reflection, the direct reflection of D-glucose. Okay, now we're going to come back to this in a little while, and we're going to change the molecules in just a second to get the different definitions to apply. But L-glucose and D-glucose are examples of enantiomers of one another. Anomers. Now, when you talk about cyclic sugars, you're always going to talk about an alpha configuration of a sugar and the beta configuration of a cyclic sugar. The difference between them really is a hydroxide group positioned upward or is it positioned downward and on that new chiral center. So whenever we talk about cyclizing a sugar, there's a new chiral center that emerges in the cyclic form of that sugar, and that cyclic form or that new chiral center is going to designate alpha or beta configuration. Enantiomers are non-mirror images of one another. So this is a little bit more broad of a category. So as long as two sugars are structural isomers, or as long as they are isomers, but they have hydroxide groups in any random positions, they are going to be considered non-mirror images and therefore diastereomers. So if, for instance, I wanted to, in fact, I could go ahead and let's be wild. Let's erase this. Let's erase that. Erase that. And now let's go ahead and put this as a OH here. That's carbon number 3, has a hydroxide group on the left-hand side. Then a hydroxide group on, let's see, that would be OH. Okay. So what I did was I basically, oh, wait, no, I need to make one correction there. And you know what, I'll just elaborate a little bit. Okay, so we've got a OH, OH. If you put that same plane down the middle here, these two sugars do not reflect one another. They are not mirror images of one another. They have a number of differences in positions of these hydroxide groups. So these are examples of diastereomers. So if we go back, non-mirror images. Okay. Now, underneath that category, there are some specific diastereomers. And I wanted to go ahead and show you an example. So I'm going to erase all my hydroxide groups, all the groups on the right and left-hand side of my carbons for my central chain of glucose. Now, what I'm going to do after that is I'm going to make my structure on the right-hand side, I'm going to make it a D sugar, OH. My penultimate carbon has that hydroxide group on the right-hand side. And then what I'm going to do is I'm going to basically do the exact same thing that carbon number 4 has, hydroxide on the left, or on the right, hydrogen on the left, carbon number 3, hydroxide on the left, hydrogen on the right. Carbon number 2, I'm going to put the hydroxide group on the left-hand side of my molecule. If you compare carbon by carbon, 1, 2, well, 2 is different. So I'm going to put a little star there. 3, the same. 4, the same. 5, the same. The only difference is carbon number 2. So that makes this difference, or sorry, this singular difference makes these two sugars diastereomers. But more specifically, since there is a variation of only one carbon, these are epimers. So another way to put this is that these are epimers. They are also diastereomers. Now, this is sort of like a square is a rectangle, but a rectangle is not a square. Well, all epimers are diastereomers, but not all diastereomers are epimers. Okay, well, I hope this is helpful in your investigation into these different terms related to sugar structure, and I hope you have a good one.